Our first lecture notes of ninth grade science are Chapter 1, Introduction to Earth Science. So because these are our first lecture notes, just a couple of reminders on those taking notes factors. Writing all red text, do not paraphrase. If you see a word in red, you write it down, make sure it's neat. Underline vocab terms. If it's a heading, make it so you can see it's a heading. So here's a heading, Chapter 1, Introduction to Earth Science. So make sure that is somewhere on your notebook. Boom, I can easily see it. There it is. So in this section, Chapter 1, Introduction to Earth Science, we're just going to be going over some basics, real basic things that are really helpful for us for the rest of the year. So what is the basic structure of the Earth? There's actually 5 sections in this chapter. You can see we start off real easy. What is Earth science? A little bit about looking at a view of the Earth, representing Earth's surface, Earth system science, what is scientific inquiry. So there's actually a lot of stuff in this section. Planet Earth is a series of giant systems, and even though sometimes they may not seem like they're connected together, everything's connected together. Earth is composed of systems of air, rock, water, and life. They're all connected. They're all connected. This is a place that I would love to go to. I have yet to go to it. I have been to the national park that is just south of it in the United States, but this is the one that's in Canada. So it's Banff National Park in Canada. Look at that gorgeous glacial lake there. And part of the reason you can tell it's a glacial lake is that really cool, pristine blue water. And if you want to see that in the United States, you go to Glacier National Park, which is just south of that in Montana. Same deal. You get that just beautiful glacial water there. It's just absolutely crystal clear. So looking at this picture, you ask yourself, what features can you identify in this photograph? What things can we see here? Obviously, we see mountains off in the distance. We maybe see some light sand debris down at the bottom. We see a lake down at the bottom there. And the cool thing is now that we're in an earth science class, we're thinking like geologists. So a geologist looks at this picture and really starts piecing it apart and starts looking at things. This is a puzzle to them. Even looking at the mountains in the background, you can start looking a little bit closer and notice there's some layers in there. You can start really noticing, hey, we can kind of tell what is going on in that picture. How do you think the lake was formed? I kind of gave it away in the beginning, talked about glaciers. But you can look at the area, look at the topography in that area, same thing. How was that lake formed? So then the last question on the slide, how could an earth scientist use this photograph in their work? Those are the things that I was just talking about. So a geologist, an earth scientist is going to be look at these things, and you can actually piece together what happened in this area in the past. It's almost like they're a criminologist trying to figure out, what happened at a crime scene. I can look at this and I can tell, even though there wasn't someone there, possibly there wasn't someone to write down what happened here, millions of years ago, I can tell we know how things happened. So section 1.1 is what is earth science. So here we have another heading in red. So once again, make sure you write that down in your notebook. 1.1, what is earth science? So in this section, we're going to be talking about what is the study of earth science. How did Earth and the solar system form? Our vocab, we got earth science, geology, oceanography, meteorology, and then astronomy. Just a nice little basic layout of some earth science topics. I'm going to start up with a little video here.
Our local neighborhood in space is thought to contain at least 250 billion individual stars. One of these stars is special. The Sun is not an exceptional star in any way. It is not the biggest, or the hottest, or the oldest. What makes it special is that it is the only known star to support a planet that harbors life. Like the Sun, the Earth is not a special planet in any way, not exceptionally large or small, hot or cold, or even composed of unique elements. But it is very special in that it is home to life. Nearly 9 million unique species of living things roam our planet, something that we have not yet discovered. this exceptional place is appropriately called Earth science. This field can be divided into three main areas: astronomy, meteorology, and geology. Astronomy is the study of the entire universe, including galaxies, stars, planets, and moons. Astronomers explore the laws of motion and gravity and how they control the movement of the Earth and all other celestial objects. They use massive telescopes to peer back into time to better understand how we got here and where we are going. Meteorology is the study of the Earth's atmosphere, the thin, fragile shell of gases surrounding our planet. Meteorologists explore everything from weather and climate patterns to global climate change. They strive to understand how energy travels and is transformed through the air and water surrounding the Earth. And finally, there is geology. Geologists study the solid Earth and how it changes from the surface down to the core. They examine rocks and minerals, volcanoes and earthquakes, the oceans, and various landforms and landscapes. They also hypothesize about the characteristics and conditions of the interior of the planet, down to our iron-rich, dense, hot core. Earth scientists strive to understand the history and the future of the Earth, where it came from, how it functions in space, and what the future holds for us. While our planet faces unprecedented challenges, including overpopulation, pollution, the depletion of natural resources, and the unpredictable impacts of climate change, this field holds a new and increasingly critical importance. After all, we can't prepare for the challenges of the future without understanding how we got to where we are today.
So one of the good things about science is a lot of those words that you guys heard in there, if you kind of know the prefix, or you know those root words in there, they really kind of clue you into what they actually mean. So overview of Earth science. Earth science is a group of sciences that study Earth and its neighbors in space. So it actually encompasses a lot of things, as you just saw in the video there. It's not just, we think of Earth as this, solid sphere. It is much more complex than that. So we can break it up into obviously a little bit smaller parts. If we're talking just specifically about the study of Earth, we call that geology. That prefix geo means earth, and then ology at the end is the study of. So it literally means, when you look at the word and you break it up, it actually means the study of Earth. So this includes the topics of geochemistry, geophysics, geobiology, paleontology. Once again, look at those prefixes. I got geochemistry, chemistry of the earth, geophysics, the physics of Earth, geobiology, so life going on with Earth. And then finally, most of us have heard of paleontology because as little kids, we love dinosaurs. Most of us do. So that is that study of ancient life. Historical geology studies Earth's history by establishing a timeline of physical and biological events. So when we look at historical geology, we're looking more at the whole entire picture. So all of the things that are going on, not just from that Earth perspective, but also biological perspective, that life perspective of how things have changed on Earth. Physical geology is examination of the materials that make up Earth and the possible explanations for the processes that shape our planet. So physical geology is different in that it doesn't include that biological factor. Physical geology is really centered around, let's look at Earth as a planet, look at the hard sphere of planet, the stuff that's going on in the surface, and that is physical geology. So historical, including that life factor, physical, not. So historical, life factor. Here I see a fossil of, looks like probably a turtle or a tortoise in some capacity. There's that life factor. Whereas physical geology, we're looking more at it from the perspective of how were those hills formed? How were those features formed from a sort of geological perspective? We have a lot of ocean on Earth. We got a lot of ocean, right? So we're mainly ocean on Earth from a percentage wise. Oceanography is the study of the ocean, studying the composition and movements of water, coastal processes, seafloor topography, marine life. Love oceanography. The ocean is fascinating. We haven't even delved into everything that's in the ocean there. Just absolutely Super cool space to learn about. Very complex. Meteorology. Most of us, if you're forced to watch the news, sometimes at nighttime, you may hear the meteorologist, and that meteorologist comes on and tells us about the weather. So, meteorology is the study of the atmosphere and the processes that produce weather and climate. So, meteorologists study weather. Fascinating. Where we live in northern Minnesota, totally makes sense, right? Constantly changing weather up here, get a 40-degree swing within a couple of days here, but that's what meteorology is. It's just specifically looking at the weather on Earth. When we move beyond Earth, we're now starting to get in the field of astronomy, so the study of the universe. So we're studying objects in space, studying objects in our solar system, studying objects beyond that, but that is the field of astronomy. Super brief, formation of Earth. This just does not even do it justice here. I do like the picture on the side. So how we believe Earth formed, what we've done is we study how we see other solar systems forming, how we see other planets forming in the universe. We take a look at that, and then it really gives us a clue on probably how things formed here. So formation of Earth and the other planets formed at around the same time. We call it the nebular theory. So we use the word theory a lot in science when we don't have actually specific record of it. We just have a lot of evidence. So lots and lots of evidence to prove it to be true. We just don't have actual evidence of it. So that's why it's called a theory. It is called the nebular theory because we believe it was created from a cloud that we call a nebula. And that nebula essentially was made of hydrogen and helium, a few heavier elements, collapsed in on itself for whatever reason. Maybe it bumped into another galaxy, maybe nearby exploding star. That entire body of gas and dust collapsed in on itself, forms this rotating cloud, crazy hot in the middle where our sun is formed at, rotating. That matter starts to coalesce in certain locations. When that matter coalesces, gravity pulls it. If there's enough, it's going to pull it into that spherical shape. As we know of planets, all of our planets, right, moving around the solar system in the same direction, everything's rotating. Everything gives us the evidence as to this is how Earth formed.
To collapse under its own gravity and spin faster, a dense clump of matter formed in the center. It's called a protostar. At first, its heat was due to friction, but when the clump reached 18 million degrees Fahrenheit, nuclear fusion kicked in. 4.5 billion years ago, our star was born. Hydrogen atoms fuse together to form helium, and in the process, release photons. It's the first light made by our sun, and it will keep on shining for 4 billion years. A vast nuclear furnace nearly 1 million miles across. From a distance, this process seems almost peaceful, with the sun's power gently radiating out into the early solar system.
There was all sorts of activity going on. Things were changing rapidly, violence, explosions, intense radiation. We had a pretty spectacular origin, I think.
Recent research suggests the solar system's birth was far from peaceful. Our sun may in fact have been born out of one of the most violent events in the cosmos. The explosive death of another star. And even before that, it seems there was an explosion so huge that it created an entire universe. The Big Bang. No one knows what caused it, but we think that the Bang created space, time, and all the matter in the universe. Yet for astrophysicists, such as Professor Stan Woosley, there's a puzzle. The Big Bang produced almost none of the 88 naturally occurring chemical elements.
When we look around, we don't just see hydrogen and helium. We see planets and people, and we're made out of carbon and oxygen, and planets are made out of iron and silicon. And that didn't all come from the Big Bang. It had to come from somewhere else.
Here on Earth, we have learned how to create new elements for ourselves. Nuclear technology. The same thing happens inside stars. Hydrogen and helium from the Big Bang fuse to form heavier elements. And if the star is big enough, At the end of its life, it does something spectacular. It explodes.
The energy of a supernova explosion is essentially equal to all of the energy that the sun will put out in its 10 billion year lifetime.
So I like that video because I kind of go into the life cycle that occurs with stars as well. So he talked about supernova explosion, which eventually goes into a black hole. Our star's not going to do that because it just doesn't have enough mass. It's too average, but just kind of giving us that idea that nothing's constant. It's not going to stay that way. It's not going to stay the same. Stars actually go through life cycles just like we as humans do. So things will not always be consistent, just like in our solar system. Layers form on Earth. So because of how Earth formed, because you have this body of molten hot material, the cooler stuff settles, sinks to the middle, the more dense stuff goes to the middle. Sorry, I'm getting confused here, guys. More dense stuff sinks to the middle. So that's where our iron and our nickel are. The less dense elements are going to float to that surface. And that's why we see on Earth, we have the less dense elements like silicon and oxygen making up our crust. And then we have iron and nickel on the inside. So we get different densities on Earth's surface. So what are the sciences included in Earth science? So think of all the things that we talked about today: astronomy, oceanography, meteorology. What topics are included in physical geology? So remember, historical includes life, physical does not, which moves us into our third one here. Explain how physical geology differs from historical. And then finally, the nebular theory, just a theory based on how our solar system formed, that large body of gas and dust that collapse in on itself, starts spinning, star forms in the middle, planets form around the outside of that. All right, when you guys take your notes now and we go to turn these in, you want to make sure you write your name near where it says 1.1 on the top. So these notes on the top where you have 1.1 or near the heading, you're going to write your name. You're going to take a really clear picture of it. You're going to turn it into the Schoology and the 1.1 notes folder. Have a good day.